For homework tonight, we're going to think about how you represent all possible outcomes in a table, just like you did with the roller derby game. And we're also going to think about the simulation situation we talked about earlier today with Tawanda's toys. So make sure you've had a chance to try the problems on page 12 and then correct them with this option. Suppose Umberto and Nina play the game evens and odds. They roll 2 number cubes and find the product of the numbers. If the product is odd, Nina scores a point. If the product is even, Umberto scores a point. Make a table of the possible products of 2 number cubes. Remember that product means multiply. Your table should look something like this. What is the probability that Nina wins? Well, Nina needs to get an odd product. So let's look at all the odd products in the table. 1, 3, 5, 3, 9, 15, 5, 15, 25. That's a total of 9 out of 36 possible outcomes, or 1/4. What's the probability that Umberto wins? He wins if the product is even. So if I think about it, if 9 out of the 36 times we get an odd product, that means the remaining times, 27 out of 36, we get an even product, also equivalent to 3/4. Is this a fair game? If not, how could you change the points scored by each player so that it would be fair? I know that fair means that I should be equally likely to win, or each person playing should be equally likely to win. So looking at this game, I see that Nina has a 25% chance of winning, Umberto has a 75% chance of winning. That seems a little bit unfair. So I'm going to say this is not a fair game. So how could I change the points so that it would be fair? Thinking about this, I basically need to make them worth different weights. So if I land on an odd product, I could make that worth 3 points, for example, right? Because I'm less likely to get an odd product. I'm 3 times as likely, 3/4 of the time, likely to get an even product. So what I can do here is make this worth 1 point. So it's worth 1/3 as much of the other value. So when I play the game with the different point values, that suddenly makes it more fair, because now, even though the outcomes are not equally likely, I've weighted the points so that everyone has an equal opportunity to win. What is the probability that the product is a prime number? Looking at all the products, we should see a number of prime numbers. Remember, a prime number only has factors of 1 in itself. So we have 1, 2, 3, 5, 2, 3, and 5. So the probability of getting a prime number would be 7 out of 36. What is the probability that the product is a factor of 4? Remember, factors are the numbers we multiply to make products. A factor of 4 in this case, we would have 1 and 4. So anywhere I have a 4, I'm going to circle. And then 2 and 2, since 2 times 2 makes 4. So that's a total of 1, 2, 3, 4, 5, 6. So the probability of getting a factor of 4 would be 6 out of 36, or 1/4. Oh, I'm sorry, or 1/6. Tawanda wants fewer winners for her scratch-off cards. She decides to order new cards with 6 spots. 2 of the spots on each card match. What is the probability that a person who plays once will win on the card? Let's take a look at all the possible outcomes. I know you may not have space on your work to do all of these, but you can kind of visualize it. So I could turn over the first and the second. Again, now I have a series of 6 cards. The first and the third, the first and the fourth, the first and the fifth, the first and the sixth, right? So that could be the combinations that I scratch off. I could also do the second and third, the second and fourth, the second and fifth, or the second and the sixth. I could also do the third and the fourth, the third and the fifth, the third and the sixth. I could do the fourth and the fifth, the fourth and the sixth, and lastly I could do the fifth and the sixth. So those are all different combinations that I could scratch off. So now let's take a look at where I'm envisioning that my prizes could be, because remember they're only behind 2 spots. So if I look here, do I have a winner? So looking through, I picked the 2nd and the 6th. So this would be my winning outcome. So now the probability of getting a win would be 1 out of all these possibilities. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's now 1 in 15.